Hi guys, this video is for 7.2. We're going to be talking about differential equations some more. In this section, we're going to learn another strategy for solving differential equations. And so the ones we're going to primarily work with here in this first part are going to involve a derivative and involve some expression with x and some expression with y. So we in Calc 1, Calc AB, and BC, we are dealing with first order differential equations, so that means it's our first derivative, and then separable is what we're going to be dealing with here in this section. So separable means we can actually separate the x's and the y's from each other, and we're actually going to use that as a strategy. So I'm going to move all the y's over here to be with dy, and then all the x's to be with dx. So, and again here that's kind of in layman's terms, so only y's with dy and only x's with dx. So we're transforming it just using algebra, okay? And so kind of our step one is to do that, is to separate. Again, that method is separating the variables, so putting the y's with dy, x's with dx, and then we're going to integrate both sides. And our solution is going to be called a general solution. This one is always going to involve a plus c. And then we can also be asked to find a particular, or you might hear the word specific. Same thing, okay? Specific solution. So, and that will give us an x and y to substitute and to find our c. Okay, so let's do an example here. All right, so we are asked to find the general solution of this differential equation, okay? And they give us a restriction on y, that's okay. We are going to follow those steps. So I am going to just rewrite this here so we can see the algebra happening. Okay, so I want to move the y's over here. So I'm going to divide by y squared, okay? And so that's the same as multiplying by 1 over y squared, right? So that's going to get rid of my y's on this side. Then, to get the x and dx together, I'm going to multiply by dx. So that's going to get rid of the dx's over here. So I have 1 over y squared, which I can write as y to the negative 2 as well, equals 3x dx. So we have an expression with y's with dy, expression with x with dx. Okay, so that's step one. Just get all the y's on one side, all the x's on the other. Then step two is integrate both sides. So we're going to apply our integral. Using my power rule here, I'm going to get y to the negative 1 divided by negative 1. And then 3x, the 3 stays. We add an exponent of 1 and then divide by that exponent. Now we are going to include a plus c for our general solution. And you might say, well, do we have to do it to both sides? Actually, no, because if I add c to both sides, those c's are just going to cancel, right? I could easily subtract that off, and then it's like I didn't have a c at all. So we're actually only going to add it to one side. It doesn't really matter which side you add it to. We will typically see it with x. It's totally up to you which one you put on. We don't usually see negative exponents in a final expression, so I'm just going to rewrite this as negative 1 over y equals 3 halves x squared plus c. So this is our general solution, okay? Now we're asked to find a particular solution, and they're giving me an x and a y coordinate. So I'm going to substitute those in to find what my particular c is. So we are going to substitute 2 for y and 1 for x. And then we're solving this for c. So we've got negative 1 half equals 1 squared is 1 times 3 halves. Subtract our 3 halves, we get negative 4 halves. And then that's just negative 2. So my specific solution is the same equation, but we're going to go ahead and replace c with our particular value that we just solved for. Okay, let's do another example just like this. Okay, again, we are asked to first find the general solution and then our particular. We always need the general before I can do the particular anyways. So part A, let's get all of our y's together. So again, I'm going to divide by y, which is the same as multiplying by 1 over y. And then I'm going to multiply by dx to get rid of the x's. So what I'm left with is 1 over y dy equals sine x dx. Okay, once I have my y's and x's separated, integrate both sides. Here I get the natural log of the absolute value of y equals negative cosine x. And then again, for the general, we're going to include that plus c. Particular solution, we're going to substitute in e for y. E is positive, so I don't actually need the absolute value there anymore. And then 0 for x. Okay, solving for c, natural log of v is 1. Cosine of 0 is 1, but we do have that negative in front. Add our 1 over, so we get 2 for c. So my particular solution, natural log of y is equal to negative cosine x, and then plus 2. This is totally fine, you guys, how we have left our general solutions not as y equals. Sometimes you might have to do some algebra manipulation to get y by itself if you're trying to match your answer with a natural log, or excuse me, with a multiple choice solution. So like I could apply e to both sides to get rid of my natural log, and then I'd have y equals this. So just be aware of that sometimes multiple choice answers might rearrange this, and we have to be aware of that. Okay, that is it for those first couple examples. Thanks for watching.